Now we'll be looking at inverse of 3 cross 3 matrix. Please look at the previous slide to find the determinant of a matrix. Please like, share and subscribe this particular channel. Let us start now. Now coming to the inverse of 3 cross 3 matrix. I'll be showing the steps to be followed to find the inverse of a 3 cross 3 matrix. Okay. The first step is nothing but calculating the minors of a matrix. Okay. I'll be showing you how to do it. Okay. The second step is nothing but then turn that into matrix of cofactors. We'll find the cofactors. Then the transpose of cofactors is nothing but adjoint. We'll be finding the adjoint. Then we'll be multiplying adjoint with 1 by determinant. Then we get A inverse. Okay. So general formula is nothing but A inverse is equal to adjoint of A by determinant of A. We'll be following with this particular example. Okay. First we'll be finding the minors of a matrix. Then coming to the matrix of minors. Okay. Minor is nothing but is a determinant of the square matrix formed by deleting one row and one column, right, from the same larger square matrix. I will explain you what is it. If you consider this particular example, same example, okay, and we're writing down all the matrix of minor, right. For this one, what you do is nothing but you consider the 3 term. You'll be deleting the row and column. Okay, it is nothing but A11, right? It is 3. Now we consider this particular matrix after deleting the one row and one column. So it becomes 0, 3, 1, 4. Now we are defining the determinant of it, which is equal to nothing but 0 into 4 minus 3 into 1, which is equal to minus 3. Then this particular first term is nothing but minus 3. Similarly, consider second term. Okay, it is 2. In this one, we will be deleting the row and a column. Then we get nothing but 2, 3, 1, 4 matrix, and we will find the determinant of it, which is equal to nothing but 2 into 4 minus 3 into 1. It becomes 6 minus 3, which is equal to nothing but it becomes 3. So this is 3. And consider first term. Next term is nothing but 1. So delete the row and the column. So we get the matrix as 2, 0, 1, 1. So determinant of it is nothing but it becomes 2 into 1 minus 0 into 1, which is equal to nothing but it becomes 2. So next term is nothing but 2. Again we will find the next value, it is 2, right? We're deleting the row and a column. Then we get the matrix as nothing but 2, 1, 1, 4. And we'll find the determinant of it, which is equal to nothing but 4 into 2 minus 1 into 1, which is equal to number 8 minus 1, which is equal to 7. So this particular value is nothing but 7. And consider 0. Again we'll be deleting the row and a column. Then we get a square matrix, right? So it becomes 3, 1, 1, 4, which is equal to nothing but 4 into 3 minus 1, which is equal to 12 minus 1, which is equal to nothing but it becomes 11. So this one is 11. Now consider the other term, 3. So find the determinant of a square matrix again. So we'll be removing the row and the column. So it becomes 3, 2, 1, 1, which is equal to nothing but 3 minus 2, which is equal to 1. So this is nothing but 1. And consider the first term. Then we get again the 2 by 2 matrix, right? Remove the row and a column. So it becomes 2, 1, 0, 3, which is equal to 6, right? So it becomes 6. Again 1, right? Remove the row and column. So we get a 1 more matrix. So it becomes 3, 1, 2, 3, which is equal to nothing but 9 minus 2, which is equal to 7. So this is nothing but 7. Again the next term, 4. Remove the row and a column. So we get 3, 2, 2, 0, which is equal to minus 4. So this is nothing but minus 4. This is a matrix we got, right? It is nothing but minors of a matrix E. Now in this particular case, what happens is nothing but Since there are lots of rows and columns, right? In ordinary matrix, you can make lots of minors from it, right? You can do lots of minor of it, right? These minors are labeled according to the row and column you delete, right? There's not one whichever element you deleted, right? The determinant will be going there only, right? Now to find the inverse of a matrix, first we got a minus of a matrix, right? So we got minus of A is given as nothing but we got as minus 3, 5, 2, then 7, 11, and 1, 6, 7, and minus 4. From this one you have to find the cofactors, the second step, right? Now come to the cofactors, okay? You have to find the minors. How to find the cofactor? Cofactor is nothing but minus 1 power I plus j m of ij. M is nothing but row, j is a column. Okay, if you consider the first term, this is nothing but minor 1 1. This is a minor 1 2. This is a minor 1 3. Similarly, this is nothing but minor 2 1. This is a minor 2 2. This is a minor 2 3. And this is nothing but minus 3 1. This is a minor 3 2. This is a minor 3 3. Right. Now we have to find the cofactors. This is nothing but C1 1. Cofactor 1 1 is equal to minus 1 power 1 plus 1 into minor of 1 1, which is equal to nothing but we get as nothing but minus 1 square into minus 3, which is equal to nothing but we get as minus 3 only. Similarly, cofactor 1 2, which is equal to minus 1 power 1 plus 2 into minor of 1 2, we get as nothing but minus 5. Similarly, cofactor 1 3, which is equal to minus 1 power 1 plus 3 into minor of 1 3, which is equal to nothing but we get as 2. In general, what is a cofactor is nothing but there will be only sign changes, right? In general, in 3 cross 3 matrices, the sign changes will be in this particular format: plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, these are the sign changes. Only we'll be multiplying with this particular terms with a minus. Okay, if you consider this particular matrix, okay, then cofactors becomes nothing but we'll be multiplying this term, this term, this term, and this term with a minus. So it becomes minus 5, minus 7, minus 1, and minus 7. Okay, this becomes nothing a cofactor. So we got a cofactor, right? So the cofactor of a matrix A is equal to nothing but it becomes minus 3, minus 5, 2, minus 7, 11, minus 1, 6, minus 7, minus 4. These are nothing but cofactors. Now you have to find the step 3, right? Transpose of a cofactor. What is the transpose of a cofactor is known as the adjoint. So we'll be finding the adjoint of a matrix A, which is equal to nothing but cofactor of A transpose, right? So we get that's nothing but it becomes minus 3, minus 5, 2, minus 7, 11, minus 1, 6, minus 7, minus 4. These are nothing but adjoint of a matrix. Just will be converting row to column, column to row. Now to find the step 3 is complete. Step 4 is nothing but we'll be multiplying adjoint with a 1 by determinant. So we have to find the determinant. So from here we'll find the determinant of a matrix C, which is equal to nothing but it becomes 3 into 0 minus 3, then minus 2 into 8 minus 3 plus 1 into 2, right? So it becomes minus 9 minus 10 plus 2, which is equal to minus 17. So A inverse is equal to nothing but it becomes minus 1 by 17 into the matrix adjoint of A, which is minus 3, minus 7, 6, minus 5, 11, 7. minus 1, minus 4. This is nothing but A inverse of a matrix. These are the steps required to find the inverse of a matrix. This is a lengthy method, right? I'll be showing you the shortcut method, how to find the inverse of a matrix. Now I'll be showing the shortcut way to find the inverse of a matrix. Okay. For this one, A matrix already we have known, and we have find the A inverse, right? For finding the adjoint of a matrix, it's a long process, right? You have to find the minor, then cofactor and transpose, and we have to get the adjoint of A. So to find the adjoint of matrix A, it takes a lot of time. Now I'll be showing you the shortcut way to find the adjoint of a matrix. For this one, what we do is nothing but consider the middle term in 3 cross 3 matrix. Consider middle term, then go to the right and come back. Okay, and write down the numbers. It becomes 0, 3, 2, 0. Right? You have started here, right? Then we be going down here, going to the middle term, going to the right and come back. So it becomes 1, 4, 1, 1. Again, you are going to top one, going to the middle term. It's nothing but 2. Going to the right and then coming back. So it becomes 2, 1, 3, 2. Okay. Again, we have started here. So again, we'll be repeating this particular values again. Go to the right and come back. So it becomes 0, 3, 2, 0. Now in this case, what you do is nothing but will be multiplying these particular values. Okay. Now, if you are writing each and every one, it is nothing but 4 into 0 minus 1 into 3. Right. So it becomes nothing but minus 3. Right. Consider this term as nothing but say 2 cross 2 matrix. Okay. And find the determinant of it. Okay. Again, consider this one 3, 2, 1, 4. Cross multiply it. Then we get as nothing but 3 minus 8. Right. So it becomes nothing but minus 5. Right. Yeah. Multiplying in this particular row form. And you'd be writing in the column form. Okay. Then 2 minus 0. So it becomes 2. Then again this one. This row. This becomes this column. So it becomes 1 minus 8. So it becomes minus 7. Again, the next term. Multiply this two. 12 minus 1. So it becomes 11. Again this one. 2 minus 3. Right. So it becomes nothing but minus 1. And coming here. We'll be multiplying this particular row. And we're writing in the form of columns. So it becomes 3 to 6 minus 0. So it becomes 6. And it is nothing but 2 minus 9. So it becomes minus 7. And this is nothing but 0 minus 4. So it becomes minus 4. So we got an adjoint of an matrix. This is nothing but adjoint matrix. The same thing has been written here. And we can find the determinant, and it becomes nothing but an inverse of a matrix. This is a shortcut way to find the adjoint of a matrix A or inverse of a matrix A. One more question on find the inverse of a matrix. Okay, we know that A inverse is equal to nothing but adjoint of matrix A by determinant of matrix A. First we'll find the determinant. So find the determinant of a matrix A. We know how to find it out, right? So consider first term, it is 1, and cross multiply these two, it becomes 0 minus 1 minus 0. Second term, it's 0, so if you multiply it becomes 0 only, so it becomes plus. Third term, it is 1, just multiply it, minus 1 minus 1, right? It becomes minus 2, so which is equal to minus 3. So we got the determinant, which is equal to minus 1 by 3. Now we have to get the adjoint of a matrix. We have to multiply this one with adjoint of a matrix, right? So first would be using a shortcut method. First we'll be taking the middle term, going right and coming back and writing down the numbers. We get as 1, 1, minus 1, 1. Then coming to the next term, 1, 0, 1, 1. Then again 0, 1, 1, 0. Again 1, 1, minus 1, 1. Right. Now it will consider this term as an 2 cross 2 matrix and will be multiplying. It becomes 0, minus 1. So it becomes minus 1. And multiply these two. 1, minus minus 1. So it becomes plus 1. Right. So again minus 1, minus 1. It becomes minus 2. Then this one nothing but 1. And this is nothing but 0, minus 1. So it becomes minus 1. And this is 0, minus 1. So it becomes minus 1. This is 0, this is minus 1. So it becomes minus 1. Minus 1, minus 1. So it becomes minus 2. And this 1 is 0. So it becomes this is nothing but an adjoint of an matrix. So we got an A inverse. It's a simple thing, right? Now come to the important points of inverse of a matrix. The first one is nothing but inverse of a matrix can be find for non-singular matrix only. What is a non-singular matrix? It is nothing but when the determinant of a matrix A should not be equal to 0. Right? Come to the second point. If B is inverse of A, then A is also inverse of B. What is saying nothing but if A inverse is equal to B, then we can say that A is equal to nothing but B inverse. Okay. Come to the third point. A into A inverse is equal to I. I is nothing but unitary matrix. If you consider 2 by 2 matrix, it becomes 1, 0, 0. Alright. Come to the fourth one. K into A inverse is equal to nothing but K inverse into A inverse. Okay. K is nothing but scalar value. A is a matrix. Now come to the important points of adjoint of a matrix. The first one is nothing but adjoint of an AB is equal to adjoint of B into adjoint of A. The second one, adjoint of K into A is equal to K power n minus 1 into adjoint of an A. Okay. Come to the third one. A into adjoint of A is equal to determinant of an A into unit matrix is equal to adjoint of A into A. As we know that A inverse is equal to nothing but adjoint of an A by determinant of an matrix A. Right. When you multiply this one with an A, this one also with an A, then we know that this is nothing but I. Then I, this comes up and becomes nothing but determinant of matrix A is equal to A into adjoint of a matrix A. The same thing has been written here. Okay. Now come to the next one. Determinant of adjoint of A is equal to determinant of A power n minus 1. What is n? Is nothing but matrix. Order of a matrix. If A is n cross n matrix, then it becomes determinant of A power n minus 1. Okay. Fifth one. Determinant of adjoint of A is equal to determinant of A power n minus 1 power 2. Okay. N minus 1 square. This is nothing but an important points of inverse and adjoint of a matrix.